1956, it was apparent that the coming year held in store a busy program for the production and delivery of the F-102A all-weather interceptor. Cold weather testing of the F-102 was accomplished at Ladd Air Force Base, Alaska. With temperatures averaging 30 degrees below zero, the program included cold soaking the airplane. That is, leaving the aircraft exposed to weather conditions previous to flight without special protection. Ground support equipment and personnel to operate it were flown from Wright-Patterson to the Alaskan base. The purpose of the test program was to observe possible effects of extreme cold weather conditions upon ground and flight operations. After servicing, the airplane, piloted by Captain Tracy B. Mathewson, took off on its first cold weather mission. The F-102 was flown an approximate total flight time of 16 hours. Each flight lasted about 1 hour and 15 minutes. On one flight for rocket firings, the airplane attained a speed of Mach 1.5 and fired 17 rockets. All systems of the airplane functioned normally throughout the tests, in spite of the extremes of cold weather to which it was subjected. The cold weather tests were rated as highly successful. During this same period, trainer versions of the F-102 were being tested and checked out at Edwards Air Force Base, California. Before each initial flight, instrumentation checks, engine run-ups, and all other pre-flight requisites were performed on the airplane. The TF-102 is the only Century Series airplane with a side-by-side seating arrangement. The instructor sits on the right side of the student pilot. The TF is equipped with the same power plant as the F-102A and carries a like armament load. It has the same fuselage with the exception of the nose section. The delta wing and tail section are identical. In the first models, buffeting was encountered at transonic speeds. Vortex generators were installed on the leading edge of the canopy. This eliminated the trouble, and the buffeting disappeared. To keep abreast with the expanding test program on the F-102A, a new facility was constructed at Edwards Air Force Base. The main hangar is 200 feet wide and 600 feet long. This central structure is flanked on either side by smaller buildings, each 40 by 200 feet, affording adequate space for operations associated with the actual engineering flight test program. About this same time, a Convair-designed rocket sled was used in rain erosion tests. The purpose of the test was to evaluate the effect of hydro forces upon plastic radomes and other materials traveling at transonic and supersonic speeds. Sprinkler nozzles were placed along a 2,000-foot section of the 10,000-foot track. Water from the nozzles was regulated to simulate a rainfall of 8 inches per hour. On this run, the rocket sled attained a speed of 1,670 miles per hour, the equivalent of Mach 2.115. This run set a new world's record for ground sled vehicles. Results of the test verified engineering design concept that the F-102 would be able to fly at supersonic speeds up to 50,000 feet or more through 1 inch of rainfall with little damage to the radome. The first Delta Wing supersonic all-weather F-102A interceptor to be delivered to a United States Air Force squadron rolled out of its hangar at Palmdale, California, May 1st, 1956. Lieutenant Colonel Charles E. Rigney accepted the interceptor for the Air Force. Commanding officer of the 327th, Lieutenant Colonel Rigney, received a checkout from Convair pilot Rex Worden before taking off for the 40-mile flight to George Air Force Base, Victorville, California. The Palmdale facility is Convair's production flight test center. It is from here that deliveries of the F-102A to the Air Force are made. During the flight, the interceptor exceeded the speed of sound twice, unintentionally. On arrival at George Air Force Base, Brigadier General James W. Andrews was on hand to welcome the Air Defense Command's new weapon. Members of the 327th Squadron crowded around the airplane for a close examination of their first F-102A. and the new aircraft became a full-fledged member of the application of the squadron insignia. Currently, the 327th Squadron is up to full strength with its authorized complement of F-102As. During the year, many important test programs were conducted. In early flights of the F-102, the noise and vibration called buzz was encountered in the air inlet ducts at speeds of Mach 1.2 to Mach 1.3. At Edwards Air Force Base, California, design modifications on the air intake duct configuration were instigated. Tests showed that an extension of the ramp would eliminate the problem. On production installation, a casting was fabricated in 2 sections, allowing easy access to the radar compartment. The extended ramp was added to production models, and the buzz was eliminated. After early tests and flights, it was decided to increase the vertical fin area of the F-102A. This modification was brought about because of pitch roll coupling encountered on another Century Series airplane, and accelerated because the problem was found in flight tests of the YF-102 and the YF-102A. During the middle of June 1956, at Convair's Palmdale facility, work was begun on the big tail modification program. Changeover to the larger vertical fin involved considerable equipment, parts, and manpower. With tips, leading edges, access doors, wiring disconnected, and plumbing removed, the small tails were carried away. The larger tails were set in place, and electrical connections, control cables, and plumbing were replaced. There were approximately 41 vertical fins modified on the F-102A and TF-102A under this program, all of which were accomplished on schedule. Concurrently with the modification program, production models of the airplane were assembled with the increased vertical fin area. This installation gave the airplane even better flight characteristics than before. It eliminated any effect of pitch roll coupling. Maneuverability was increased, and aerial maneuvers were accomplished with ease. In July 1956, the first F-102 equipped with a side stick was delivered to Edwards Air Force Base for test evaluation. The control stick was relocated from its center position to the right-hand side of the cockpit to prove out the design concept. During the middle of August, Major General Albert Boyd, Deputy Commander for Weapons Systems ARDC, arrived at Edwards Air Force Base to fly the side stick airplane for Air Force evaluation. In flight, the airplane handles like the conventional F-102. Flying with the side stick is a matter of familiarization. The General flew for 38 minutes, and on landing, discussed the characteristics of the side stick airplane with engineers and Air Force personnel. If there is any question of performing coordinated aerial maneuvers with the side stick, watch this one with John Fitzpatrick, company test pilot at Edwards. Of an Air Force decision, the center stick will be retained as standard equipment on production models. During this period, another airplane was being fitted with external wing tanks for flight test evaluation. These are a standard tank used by the United States Air Force on other aircraft, and when installed, will increase the ferry range of the F-102A and reduce the number of refueling stops. The tanks weigh 89.5 pounds empty and have a capacity of 230 U.S. gallons each. With ground tests complete and all data compiled and evaluated, the tests took to the air. One of these was the dropping of the tanks to make sure they could be jettisoned safely. The tanks are actually shot away from the wings with an ejection unit to get them away quickly and without damage to the airplane. With all tests proven satisfactory, present models of the airplane have provisions for attaching the external tanks. pilot ejection from the TF-102 tactical trainer was given much attention, and many high-speed runs were made to study ejection methods. Tests will be continued in 1957 with a rocket-propelled seat, and present indications are that the rocket ejection system will take a seat and pilot higher and with more stability than the M3 system. The forward component of thrust made possible with this concept will soften the rearward jolt which occurs when the pilot is catapulted abruptly into a high-speed slipstream. Low-level ejections will also be more successful. An active armament test program and aerial firings, including MB-1 and 2.75 rockets and Falcon missiles, was conducted throughout the year at Holloman Air Force Base, New Mexico. A tethering rig was used to suspend the F-102 for testing of the MB-1 rocket. For the tests, the airplane was stripped of all non-essential equipment and the engine removed. Between firings, the F-102 was lowered for examination. The MB-1 develops a thrust of 37,500 pounds. Ground firing such as this proved the airplane-to-missile relationship satisfactory. Visual examination of the F-102 revealed no significant effects of blast pressure or temperature. The 1797 F-102A is a standard production model. However, it features a retractable rail launcher designed to carry the rocket within the bay until time for firing. The purpose of the tests is to prove out the airplane's ability to fire this rocket within a performance envelope. The flight plan is worked out in detail prior to takeoff. The pilot receives all his instructions from the vectoring crew on the ground. From the camera's eye, it looked like this. The aerial firings of the MB-1 from the retractable rail launcher are proving out well. Further tests are currently in progress. Concurrently with the rail launchings of the MB-1, another method of launching the rocket was being tested. This is a downward ejection system. The slow-motion camera provides an opportunity to study a ground test firing at close range and reduced speed. Prior to hot firings from the airplane, in-flight inert drops were made to check out the system. During December 1956, the first hot firing utilizing the downward ejection system was performed with the 1806 airplane. Both of these MB-1 firing systems will be tested for further evaluation in 1957. The Falcon missile program was running concurrently with that of the MB-1. The TF-102 carries the same armament as the standard F-102A, and aerial firings were conducted from the TF at Holloman Air Force Base, New Mexico. The two-man loading crew loads the first of 6 Falcons and makes sure the bird is properly seated in the launcher. With loading complete, the doors are closed, and the airplane is ready for a run on the firing range. Having successfully completed the Falcon firing tests, bay doors of the TF are being refitted for firings utilizing the 2.75 rocket. In August, deliveries were begun of F-102s to activated operational squadrons based at strategic points in the United States. General J.B. Crabb and Colonel R.L. Gould arrived at Palmdale Air Force Base facility to take delivery of the first 2 F-102s for the 11th Fighter Interceptor Squadron based at Duluth, Minnesota. Major General Crabb is Commanding General of the Central Air Defense Command, which comprises 21 states from Mexico to the Canadian border. A leisurely flight was made because of weather and darkness policies affecting new aircraft. The arrival of these first two Delta-winged supersonic jet interceptors marked a new milestone in the progress of military preparedness in this area. Mayor Lambert of Duluth, Minnesota, was on hand to greet the pilots with a warm welcome. Lieutenant Colonel Pappy Myers, commander of the 11th Fighter Interceptor Squadron, inspected the aircraft with Colonel Gould and Captain Hart. Delivery of F-102s to other squadrons continued at an accelerated pace. The highlight of the 1956 program was the first flight of the all-new F-106A. Some of the differences between the F-106 and the F-102 are readily discernible. The inlet ducts are larger and placed further aft on the fuselage. The vertical fin has slightly more area. The F-106 is a bigger airplane, measuring more than 70 feet in length from the tail to the tip of the probe. The F-106 carries one MB-1 rocket and 4 Falcons. This is comparable to the F-102A. 2 taxi runs were conducted before the F-106A was ready to fly. On December 26, 1956, the F-106A was ready for its first flight. Takeoff was accomplished without afterburner, which is comparable to the F-102A takeoff with afterburner. The F-106A is equipped with a J-75 engine, which develops a static thrust of 23,500 pounds at sea level. It is capable of speeds up to Mach 2 at 35,000 feet. The first flight of the F-106A was considered very satisfactory. Additional flights are being conducted for the purpose of clearing the airplane to its tactical capabilities. Production models are expected to start rolling off the assembly line at Convair's San Diego facility sometime in June 1957. At the year's end, there were 173 aircraft delivered to flight test and operational facilities, with more coming off the assembly line at a rapidly increasing rate. Despite the incorporation of many changes, large and small, determined by both the contractors and the Air Force test programs, all production schedules were met on time, and the airplanes were delivered to the United States Air Force in the contract-required quantities for 1956. The F-102A is proving itself a capable all-weather interceptor weapon in the United States Air Force Interceptor Squadrons now in operation. In spite of the extremes of cold weather to which it was subjected. The cold weather tests were rated as highly successful. During this same period, trainer versions of the F-102 were being tested and checked out at Edwards Air Force Base, California. Before each initial flight, instrumentation checks, engine run-ups, and all other pre-flight requisites were performed on the airplane. The TF-102, in 1956, it was apparent that the coming year held in store a busy program for the production and delivery of the F-102A all-weather interceptor. Cold weather testing of the F-102 was accomplished at Ladd Air Force Base, Alaska. With temperatures averaging 30 degrees below zero, the program included cold soaking the airplane. That is, leaving the aircraft exposed to weather conditions previous to flight without special protection. The F-102 was flown an approximate total flight time of 16 hours. Each flight lasted about 1 hour and 15 minutes. On one flight for rocket firings, the airplane attained a speed of Mach 1.5 and fired 17 rockets. All systems of the airplane functioned normally throughout the tests. Ground support equipment and personnel to operate it were flown from Wright-Patterson to the Alaskan base. The purpose of the test program was to observe possible effects of extreme cold weather conditions upon ground and flight operations. After servicing, the airplane, piloted by Captain Tracy B. Mathewson, took off on its first cold weather mission.